Lesson 11.3, trapezoids. Kids, don't get trapped by the trapezoid. All right. So I think the best way to think about a trapezoid, well, I shouldn't say it's the best. One way to think about a trapezoid is it's just a special case of a triangle. And you may be saying, but Mr. Larson, how is it a triangle? I don't see a triangle. Well, you recall that a triangle is just base times height, right? Whoop, shouldn't use that one. Base times height. My height in the triangle or in the shape is kind of obvious. And you might be saying like, okay, well, what if you're doing this trapezoid here, right? Then the height would be just here, right? So the height is kind of obvious to see. What is trickier is the base. So let me put the height on this side. With a triangle, sorry about that. Let me erase my outlines here. With a triangle, there are two bases. You say, what? What do you mean two bases? Yeah, there's a base up here at 0, and then a bottom base down here. And what we're doing is we add those two bases up. Now, the reason we don't put the 0 over there is because it's 0. But with a trapezoid, you do have two bases. And if it were, say, this trapezoid, right? Then you have a base here, call it base 1, and a base here, base 2. So you just add those two bases up. All right? There's another way to think about it, and that was what I was referencing yesterday, and that is thinking about this special line, aka the median. How do you find that median? Well, if you've got a short base and a tall base, B1 and B2, just find the average of those two. Find that middle base. All right? And then that tells me, again, we would take this piece here, and I just flip it over here. And that ends up then giving me the theorem for the area as the median times the height, right? In this case, my height is best envisioned as being on the bottom, right? The height stays constant throughout this problem all the way across. All right, so pick your poison. Think of it as a triangle, or think of it as a two different bases where you're finding the average base. So I'll do each problem separately here. I got a trapezoid. They gave me one base, did not give me the other base. Dang it. And they didn't give me the height. Well, lo and behold, first thing we notice in this particular problem is that this particular triangle is not an ordinary triangle. Okay, this is a 30-60 triangle. And how do I know this is 60 degrees here, and this is 90 here, and this is 30 here? Well, the height is always measured at 90. I can see it's an isosceles trapezoid. And therefore, that's got to be 60 degrees because the base angles will be congruent. Yes? All right. So redrawing that triangle. Right? And we've got, what do we say, 6? And we've got 60. And this is 30. And this is 90. So that my short side is half of 6. And then I would take 3 times the square root of 3 to get the height. All right? So I think we now have enough of the rest of the information because I know that this is 3, and this is 3, and this is 7, and I know my height is 3 root 3. So now it becomes, you know, however you want to do it. Again, what is the average base? In this case, it would be 7 plus 13 divided by 2, which is 10. So there's my average base. So the area is 10 times 3 root 3. So the area is 30 root 3, again, units squared. All right? again, think about it as a triangle. I do it as a triangle. Area equals 1/2 height times the two bases, or the base, right? The height in this triangle is 12. The base, 6 and 14, 20. So 6 times 20 is 120 units squared. Did that one kind of fast. Hopefully it made sense to you. It's a simple problem. Pick your method, go with it, solve those trapezoids. Have fun in the homework, knock yourself